The Instrumental Analysis Unit of the FBI laboratory conducts examinations of a large variety of usually small specimens. This tiny paint chip, found at a crime scene, is to be compared with a known sample from a suspect's car. First step is the microscopic examination, which reflects such overall characteristics as color, texture, and layer structure. Microchemical analysis indicates the type of paint, in this case, nitrocellulose lacquer. If the known and questioned samples are of different types, the examination terminates here with this negative finding. If they are the same, instrumental analysis is indicated. The gas chromatograph can analyze the organic base or vehicle in which paint pigments are held in suspension. The examiner, using a microscope, puts minute flakes from known and questioned samples into tiny platinum coil holders. The coil with its paint sample is placed in the gas chromatograph. The paint will be vaporized by intense heat. The platinum holder remains unaffected. The vaporous fractions are quantitatively and qualitatively analyzed by being carried through a specially packed column by nitrogen gas. The resulting readout can identify the vehicle in which the pigment of the paint sample was suspended: linseed oil, acrylic, or others. If this differs between known and questioned sample, the examination would end with a negative report. In this case, results prove to be identical. The next step is to identify metallic elements present in the paint. The emission spectrograph records on a photographic plate the burning of a paint sample in an electric arc. Each element burns with a unique and identifiable spectrum. The optical system of the spectrograph focuses the light of the burning arc through a slit aperture, concentrates it by a concave mirror, and resolves it into spectrum components with an optical grating. Tiny flakes from known and questioned paint samples mounted in the well of a carbon electrode will be burned in a direct current arc. Elements present will emit light and produce their characteristic spectrum, which will be recorded on the photographic plate as a series of vertical lines of varying density. Other tools used in the instrumental analysis unit include the National Automotive Paint File, with panels representing manufacturers' finishes of almost every car on the road. The spectrophotometer is also used in analysis of paint that contains organic dyes and for many other dyed materials. The dye is removed by a solvent and placed in the spectrophotometer chamber. The amount of color absorption at each wavelength is recorded on the graph. This can be compared with known standards or samples. The X-ray diffractometer analyzes the crystalline structure of materials and can identify combinations of elements known as compounds. This supplements spectrographic examination, which can only identify elements. The X-ray diffractometer is also employed for the analysis of minute amounts of complex byproducts found near a suspected bombing. A comparison densitometer projects the results of the spectrographic examination. To the expert examiner, the vertical lines of varying density identify each element and facilitate the comparison of known and questioned samples. When known and questioned samples produce the same results in microscopic, gas chromatographic, and spectrographic examinations, The examiner's report establishes scientifically their similarity, and he is available to testify to his expert conclusions in court at no expense to the requesting agency.